These are the answers to page 128. The first 6 wanted you to find the second derivative of these functions. So for the first one, we'll take the first derivative. 3 halves times 4 is 12 halves, or 6, x to the 1 half. Then when we do the second derivative, we'll go 1 half times 6, which is 3, x to the negative 1 half. That's our second derivative there. For 94, the first derivative would be derivative of x, which is 1, plus negative 2 times 32, that's a negative 64, x to the negative 3. Then when we do the second derivative of 1 is 0. We're going to do negative 3 times negative 64, that's a positive 192, x to the negative 4. For 95, we're going to do the product rule, or the quotient rule to start, so it'll be bottom, x minus 1, times derivative of the top, which is 1, minus top times derivative of the bottom, which is 1, over bottom squared. Okay. And then if I simplify that, which is a good idea when I have to do the second derivative, I'm going to have x minus 1 minus x. Those x's will cancel, so I'll really get just negative 1 over x minus 1 squared. Right? So that's makes things a little bit nicer now. So when I go to do the second derivative, okay, I can still do quotient rule. I can bring the bottom up, x minus 1 squared times derivative of the top, which is 0, minus top, negative 1. So I'll just change that to a plus. The derivative of the bottom. Now, at this point, we don't know how to do the derivative of that in what's called a chain rule. We'll be doing that soon. So you would have to have multiplied that out, x squared minus 2x plus 1, and then do that derivative on your own, which is 2x minus 2. Okay, and that's over the bottom squared. Okay, so x minus 1 squared would be x minus 1 to the 4th. This zeroes out, which is nice, and so we end up with just 2x minus 2 over this right here. We will find an easier way to do that second derivative on the next section, but for right now, that's what we had to do. 96, again, we're going to use, we can do one of two things. We could either divide this out and then do it term by term, which might actually be easier, or we could do quotient rule and then quotient rule again. So really it's kind of up to you. I'm going to go ahead and divide it out because I do think that's going to be easier for us. So this is what this function looks like. If I divide all of those by x, I get x plus 2 minus x to the negative 1. So the first derivative would be 1. This is 0. And I'm going to get negative times negative 1, which is positive x to the negative 2. There's my first derivative. Then my second derivative will be 0. So it'll just be negative 2x to the negative 3. Much easier than trying to do quotient rule twice on that. Okay, so if you have that option, it's kind of a nice one to take. For this one here, derivative of 3 sine is 3 cosine. And then the derivative of 3 cosine would be a negative 3 sine. So we almost get back to where we started. It's just the opposite of what we had. And then over here, the derivative of secant is secant tangent. So now when I go to do the second derivative, I have to do a product rule. So derivative of secant, again, is secant tangent. We're going to take that derivative times tangent, the second function as is, plus now secant times the derivative of tangent, which is secant squared. Okay? So in the end here, what we get is secant times tangent squared plus secant to the 3rd. And we could pull a secant out if we wanted or just leave it, but that's what our second derivative is. Okay, first derivative is simple enough, then we had to do product rule on that to get to there. 105 through 108 gives us information, wants us to find the derivative of f at 2. The first thing you have to do is find the derivative. So the derivative based on how 105 was written would be 2 times g prime x plus h prime x. Okay, so f prime of 2 will be 2 times g prime 2 plus h prime 2. If I go get those values, g prime 2 is negative 2, so this will be negative 4. H prime was positive 4. Negative 4 plus 4 will give me 0. So first things first, take the derivative, then put 2 in, and then find the values. AP likes these kinds of problems. for this one, the derivative of 4 is 0. Derivative of minus negative hx will be a negative h prime x. So f prime of 2 will be the opposite of h prime of 2, which is the opposite of 4, or negative 4. All right. For 107, now it's a quotient, so I have to use quotient rule. The derivative of f will be the bottom function h times the derivative of g minus g, the top function, times the derivative of h, the bottom, over bottom squared. Okay, so there's my quotient rule. So when I do this f prime of 2, it's going to be h of 2, which is negative 1, times g prime of 2, which is negative 2, minus g of 2, which is 3, times h prime of 2, which is 4, over h of 2, negative 1 squared. And that's going to give me 2 minus 12, which is negative 10, over 1. So I get negative 10 for that. So that's a real popular AP. They like that kind of question. You could easily see that on one of our quizzes, tests, multiple times, in fact, just to kind of get you in the habit of something like that. Same thing here. This is just a product rule. So it's derivative of the first times the second plus the first times derivative of the second. So f prime of 2 would be g prime of 2, which is negative 2, times h of 2, which is negative 1, plus g of 2, 3, times h prime of 2, which is 4. We end up with 2 plus 12, which is 14. Right. And that's our derivative there. 115 wanted you to find the velocity and the acceleration at 3 seconds. If we put 3 into the velocity, I get 36 minus 9, which is 27. As far as the acceleration goes, if I found the acceleration function, it's negative 2t. So the acceleration at 3 seconds is negative 6. Okay? And they wanted you to know what then is going on with speed. So because my velocity is positive, my acceleration is negative, we are slowing down. Speed is decreasing because the velocity and acceleration have opposite signs. And that's the easiest way to understand this. If my velocity and acceleration agree, if they're both positive, they're both negative, then we're speeding up. If they're opposite, then we're slowing down. All right, and so that's that one there. Then we have some true-false questions. Number 129 says, if y is f times g, then the derivative is f prime times g prime. So obviously we know that's false. We'd have to use a product rule on that, and they didn't use the product rule. 130, if y is all of this, then the fifth derivative of y would be 0. Well, if you were to multiply it, your front term would be x to the fourth, and then you'd have a bunch of terms that are less than that. So the first time you do the derivative, it would go to x to the third, then it would go to x squared, then it would go to x, then it would just be a number on the fourth derivative. So if it's on the fourth derivative, just a constant, then the fifth time you do this, it will turn to 0. This is true. And then any other derivative past 5 would also be 0. 131 says if f prime of c and g prime of c are both 0, and h is the product of this, then h prime of c will be 0. And if you think about the product rule, you'll take the derivative times the other function is plus, and then you'll switch it around. Well, if each of those derivatives are 0, then you'll be multiplying by 0 on each part of that. So when you add them together, you'll get 0. That's definitely true as well. If f is an n-degree function, then the n plus 1th derivative is 0. So that means if f was a 4th degree function, then the 5th derivative would be 0. If n was a 10th degree function, the 11th derivative would be 0. This is absolutely true. That next derivative after the degree will take that constant down to 0. That's also true. Okay. The second derivative is the rate of change of the first. That's true. A derivative is a rate of change of a function, and a derivative is a function. So your first derivative is a function, so when you take its derivative, the second derivative, you're talking about how that derivative is changing. So acceleration is the rate of change of velocity. Acceleration is the second derivative, velocity is the first derivative. So that is true. And this one says if velocity is constant, acceleration is 0. That's true. Acceleration is the derivative of velocity. So if we have just a constant, then our derivative is constant.